Hello everyone. So I welcome you all to our today's learning session with Big Data. So in today's session, we are going to discuss a problem statement where we try to approach this problem statement using PySpark code. So let's get started. So first I will give a readout of this problem statement, and we shall discuss about the approach what we are basically using to solve this problem, right? So consider you have been given a CSV file containing a list of transactions with columns as shown, which are like order ID, order date, total products, order value, user ID, and so that's it. So basically, you can consider this as a sales transactions where this CSV contains the sales transactions records and user ID informations. So now what the ask is, now the consumer of this data needs more informations about the user's data, so which can be retrieved using a API endpoint. So as you can see, so we are right now consuming the data which are getting from the sales transactions. Here we only get the very minimal informations about the user, which is the user ID. So that is a specific identity of a user, right? Um, so in this scenario, we can consider that there is no separate tables where we can get the user information. Let's say like we are outsourcing the user's informations from a third-party API or something else like. So if you are given such scenario, so we shall see on how to solve this problem. Okay. So so basically, first you have been given a CSV file, right? So since you have been given a CSV file, so first we will read the CSV file and create orders data frame out of it. And after that, our priority has to be get the user's informations from the API response, right? So basically, if you see in the sales table, in the transactions table, so we have this user ID. So the number of users which is being listed on this transaction tables, so we are going to use this user ID. And basically, if you see this API endpoint, it is a dynamic API endpoint, which means, so let's say like you want to like get the information about user ID 1. So you have to change your path as dummyjson.com/user/1. So if you put that, if you make the path as 1, then it's going to like bring you the information about user ID 1. If you're going to make change it to user 3, it's going to bring you the user informations about user ID 3. So just like that, we can get every informations. So the second thing is we are going to get the response from this API endpoint and store it somewhere. And then we have to create a data frame out of the response. And also like we have to like join the existing orders DF with this customer DF. I hope you guys are clear with this. So let's get started with this. So to give you a better understanding about this API endpoint, so I'm using Postman to like send requests, send this GET request and fetch the response so that we can visualize how the response looks like and what are all the informations we are interested in, right? So here if you see, so we have this dynamic endpoint and we have changed the path of this endpoint to 70, which means I'm interested in bringing the response of user ID 70. So let me send the response. Okay, so I have received the response. Um, so if you see here, so in the response, can see the informations about the customer ID. So the user ID, the first name and last name of the user, his age, gender, email, and so on. So there's a lot of personal information which has been uh, put down over here. So let's not consider all the informations. So let's say like we are more interested on bringing the informations like first name, last name, email ID, and phone number. And let us also bring his address. So if you see here, address column is actually a kind of like a nested JSON. So let's also see how we can extract the nested JSON and bring it as a column when we are trying to solve this using the Databricks. Okay, all right. So in continuation to this problem statement, so here you can see I have already mounted this CSV file into this DBFS. So let me rerun this to show you the output. Yes, so this is the file path where exactly this customer transactions.csv is being stored. So let's get started with our PySpark code. So first of all, I'm trying to import the necessary packages, and I'm just initiating the Spark session. All right. And after I have initiated the Spark session, so I'm using the Spark sessions to read the CSV file, which is the customers transactions.csv, which is located in this particular path. So in the options, you can see that I have included the header as true, because in my CSV file, so I have included the header, which is the first row of my CSV. So that's the reason I have given the option as header true. And yes, so this is how we are reading it and showing the output of it. So let me just rerun it again. So internally, Databricks is actually running a Spark job to read this data from a CSV file. And yes, again, it's going to show us the output here. Perfect. So if you see here, so it has read the CSV in the format which I have intended to do it. So if you can see here, there are like 5 different columns, which is order ID, order date, total products, order value, user ID. So these are all the information, the data which is available within this CSV file. You can see this order ID value, date, which is in the format of DD, MM, and YYY. And this is the total number of products and the order value and the user ID. So here we are more interested on using this user ID column to fetch the a response from the API request, right? So there are different ways of solving this problem. So consider so you're working with a data frame which has around millions of rows. So if you are having a millions of rows, and if you are using a Python function to solve this problem, so as you know, like in Spark executions, so when you use explicit Python function to execute something, it's going to run on your driver machine. So whatever the load, whatever the computations which your Python function is trying to execute, it will be completely overloaded onto your driver machine. So if you want to distribute your API request to your executors, then you have to register your Python function as a UDF, and you have to distribute this API request to the executors. So since here I'm just using a very smaller data set of 100 rows, I'm just using a explicit Python function to solve this problem. So which means when I try to solve this problem by making this API request and getting the response, it means all these executions are running on the driver machine, right? So so since I'm working with this Python function, so I have to convert this data into a data structure which Python will be able to understand, right? So here the data are stored in a data frame data structure. So I'm planning to convert this user ID column into a list of all the users. So this is how I basically converted this user ID column from this orders DF data frame into a list. So what I did is, so basically I just tried to look onto the internet on how to convert this data frame column into a list. So this is what the syntax I got. So basically, if you can see from the data frame, so we are just selecting the required column, and we are basically using this 2DF. So which is we are converting it into a uh, pandas data frame, and then we are just only fetching this user ID column, and this will result me a data frame object. So from this object, I'm just converting this into a list. So just like that, I have this users list. So let me rerun it and show you the output of this users list. Okay. So I hope this is clear. So we have converted this column from this orders df data frame into a list of all the users. All right. So now our next job is basically to create a function which can use this users in this users list by iterating through each elements in this list and make a API request and capture the response, right? So since I have mentioned that I am going to use the Python function to make the API request and capture the response. So I'm importing the package which is necessary to make the API request. So which is the request library. I have imported it. So as I have mentioned, the endpoint which we are working with is a dynamic endpoint, right? Um, so if you change the path of this the final path, so you will get the informations about the each users. So within this endpoint, basically, the first initial path are static, and only the last final path is the one which is dynamic, right? So I have created a variable to store my static path, and I have created a functions which is customers data fetch, and within this I have created a list. So within this list, I will append all the responses which I get for each users in my users list API request, right? So then I'm just using a for loop to iterate over the each of the elements in the users list, and I'm trying to capture make an API request with get using this base URL and the user ID, right? So this is so let's say in the users list, the first element is 56. So my URL is going to be users slash 57. So for this, so let me also run this from my Postman so that you can see how the output looks like. So if you see here for user ID 57, I get the first name, last name, his email ID, phone number, and addresses. So this is how my output looks like, right? So once I get the response, so I have to ensure that the response which I got from this endpoint is 200, which means the status is okay and the response you got is correct. If not, I'll just print this status code. So when the status code is 200, so I will capture this response and I will convert it into a JSON object, and I will append it into this customer API response list. And finally, we are returning this customers API response list. So let me run this. So it's going to, okay, sorry. Yes. So let me rerun this. Perfect. Let me, so we have run the function definitions right now. Let me just run this function and capture this return variable. So maybe it's gonna take some time because it's going to run in a loop for at least 100 users to send the API request and capture the response. So if you can see, it has took like 6 seconds to capture the response of 100 users basically. So let me also try to print the output of this customer API responses. Okay. So as you can see, it's basically a list. Within the list, we have response of every user ID. So if you can see, the first user ID is 56, and then yeah, probably for all the users, you will have the information over here. So here we have this ID 45 and so and so. So currently, we have created this orders.df from our CSV file, and we have created our own functions to make API requests and capture the response, and then we have stored that response in a variable. So right now, our next set of process would be to convert this list and create a data frame out of it, and finally, from the data frame which we have created, we will join it with this orders df, and we can create our final data frame with the joined informations of the user's data, right? All right, I think we are clear with this. So currently we have the response of our API request for each of the users. So and here you see the list within which we hold the response. So let's try. So from the list, let's try to create a data frame. So to create a data frame, first we will parallelize this variable and create a RDD out of it. And then from the RDD, we will attach a schema since it is of struct type. So we will attach the schema to get the necessary fields, and we'll map the required fields within the nested address as well, right? So first, we have this JSON RDD, so where we have parallelized this customer API responses, and then we have like did a JSON collect. So this is how the output looks like. Let me show you. Yes. So this is basically a list, and within list, so we have this dictionary kind of structures where we store all the informations. So now our priority is to create a JSON data frame out of this RDD. So also to this RDD, so like previously as we like went on to look this response, right? So we are only focused on bringing the fields like first name, last name, email, phone, and address. So if you see address is basically a nested JSON. So first we will try to read it as a string, and later on we will see like how we can like extract the data out of this struct data type, right? Okay, um, so after creating this, so we have this df.show. So here you can see for one record, which is Samantha. So her email ID is this, and her phone number is this, and this is her address. Her address is right now in a format of like a JSON. So we will like map the each fields, each key as a separate column. So for that, we will create a new structure to it. So this is how basically the structure looks like. So within the address column, so we have this address, city, state, state code, postal code, coordinates, and within coordinates we have this latitude and longitude, and then we have this country. So I have defined the schema, and after defining the schema, okay, just leave about this. So these are all um, the schema of our existing data frame. So with the existing schema being defined, I'm using the schema with our existing DF, and I'm creating a new data frame. So here, if you see, I'm adding a new column, which is a JSON data. So here, if you see, I'm using this from JSON. So what this from JSON does is, so basically it just reads the data as a JSON type. And so basically like when we inferred the address column, so we have like inferred it as a string, but within the string it's actually a JSON type, right? So to read the string column as a JSON, so we are using from JSON. So using the from JSON, and we are also like providing the schema for it, which we have defined it earlier. It will be able to like capture the data, like keys and value within the JSON structure. And so as you can see, like this address, so let me show you here. So this address key has a value address as well. So if I try to like explode this JSON, so there will be like a two ambiguous address column, right? So in order to like fix this issue, so I have renamed the existing address column as address top node. And from this top node, so I'm just basically using this from JSON and applying the schema to it to create a new column. And then, so if you see this JSON column, so it will be like looking like a um, so okay, first let me show you that. So basically the JSON data will be looking like a struct type. Yes, if you see the JSON data, it's holding all the informations. in a JSON kind of structure. So in order to extract the data from this JSON data, so I am basically using JSON data dot asterisk. So this will like help me to like create fields out of all the JSON structure. So once I like create the structure, so I'm just dropping this phase of address top node on JSON data. So this is how our final data frame looks like. Perfect. So we have this first name, last name, email ID. Oh my God. So I think in our orders DF, so we have this user ID, and we have missed to create this add this ID in this data frame. So let me add that as well. ID. So let's see if it's bringing the ID column. Yes, we have this ID. And then let's again run this. All right, we have included this ID as part of this user div. All right. So currently, like we have like separated this problem statement into three different phases. The first phase is to read the CSV file and create this orders DF, and the second phase is basically to make an API request and get the response out of it. And based on the response, so we have created this user DF. And the final phase is basically we have to combine orders DF with user DF. So let's proceed on with that. Yes, and finally, let's proceed on with this join operations. So we basically have to join this user DF along with this order DF. So basically, the joining condition should be based on user ID. And let's try to do a left join out of it. So though we know that all the user ID available in this transaction table is available on the users DF, but still, let's try to go ahead with this left join itself. All right, so here I have performed the join operation. So I am joining this order DF with user DF, and the joining condition is based on user ID. So the joining condition is left join, and I have performed it, and this is the output. Yes, we have accomplished the output which we are basically looking out for. So here you can see this user ID, order date, total products, order value, first name, last name, email, address, city, state code, postal codes, coordinates, country, and phone. Perfect. So I hope this is clear for you. So so when you are working with this API request, right? So I would say definitely this is not the optimal way of solving the problem, because like let's say like if you're dealing with millions of records, so uh, like performing this operations and driver machine make take you like a lot of times, and you're not utilizing this parallel distribution processing. And also so I would suggest if there is any requirements which comes in to get the data from a API and then like proceed on with this transactions, it's better to move that aspect out of the PySpark. So just try to maybe like just create a lambda functions or like some EC2 functions which can make API calls, requests to API calls, and bring in the response and can store the final output in some S3 buckets in a JSON format or a different kind of file formats. And then you can later on utilize this Spark to like perform this distributed processing. So also like you can also like if you're working with the backend engineers. So you can also ask them to create some endpoints which can like try to provide like a batch of 100 users response in a single API request resource, because this can like minimize the number of API calls which you are making with this applications. So there are like a lot of ways to optimize it. So if you're really interested on discussing that, just go to our comment sessions and put out your thoughts. So I will, when I look onto this comment, I'll just try to reply on it. Okay. And yeah, thank you everyone.